Hi everyone, and welcome to the flipped recording for 3.03 chemical formulas. So as we've been talking, you do need to update your notes for this slide or page, notebook page, in your science notebook. Remember to update the lesson number and title as well. If you look at the example slide again, be sure to change this number at the top. Make sure you have notes over here and all your guiding questions and answers over here. So as we get into the content for 3.03, we're talking about chemical formulas. If you were to pour hydrogen peroxide into one beaker and water into another beaker, you'd notice that the liquids look very much alike. But what you'd learn is that they react differently with other substances. They are both compounds that are composed of atoms of hydrogen and oxygen joined together to form molecules. So why do they have different properties? Soon you will be able to answer this question. So as we get started, we have some keywords to put over in our notes. A covalent bond is a bond in which electrons are shared between the bonded atoms. A covalent compound is a compound resulting from a covalent bond. An ionic bond is the force of attraction between a charged atom or a group of connected atoms and another with an opposite charge. So remember, opposite charge is the key word to remember here. So an ionic compound is a compound resulting from ionic bonding. And a polymer. A polymer is a molecule consisting of repeating chemical units. So if we go ahead and get our guiding questions for this lesson, take a snip of those really quick so that we can answer those. The first thing we'll be looking for is what is the difference between an ionic and covalent bond? All right, so this is answered on the first page. Ionic and covalent bonds. So to form compounds, atoms can bond in two ways. A covalent bond forms when atoms share pairs of electrons. They usually contain nonmetals. Carbon dioxide is a compound formed from a covalent bond. So you have a lot of stuff right off the bat that you can put in your notes. So talking about a covalent bond, we know they share electrons, contain nonmetals, so that's important to know. And an example, carbon dioxide. Carbon dioxide is called a molecule because it is made of covalent bonds. The diagram shows a covalent bond being formed. Every 2 electrons represents 1 covalent bond. Okay, so you see the covalent bond here. You've got the 2 different atoms, and then the electrons here are shared. We know that means it's covalent, so that would be 1 covalent bond. So the image here, an ionic bond, it's different. These are formed from the electrical attraction of 2 oppositely charged ions. They usually contain a metal and a nonmetal. Table salt is an example of a compound with this type of bond. Table salt is called ionic compound because it is made of ionic bonds. The chemical formula for salt is NaCl. Salt contains positively charged metal sodium ions, so this Na+, and negatively charged non-metal chloride ions, which is Cl-. The diagram shows that in ionic bonds, one atom transfers electrons to another. So you're able to see here the electron transfer, so it's losing one and going to another. So the answer, when you're looking at what's the difference between ionic and covalent, you should be able to see that covalent share and ionic transfer electrons. Next, we're looking for what information can you gain by interpreting a chemical formula. So just how much can you learn from a chemical formula? The combination of symbols and numbers tells how many atoms of each kind of element are in a molecule of the particular compound. So that's the answer to question number 2. Combination of symbols and numbers. It tells us how many atoms of each element are in a molecule of a particular compound. So for example, the chemical formula for hydrogen gas is H2. This means that each molecule of hydrogen gas contains 2 atoms of hydrogen bonded together. The chemical formula for ethanol is C6H6O7. I think that's a 7. Oh, actually, it's just an O and a comma. So, which means that there are 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. If no number appears below the chemical symbol, it means that there is only 1 atom of that element in a molecule of that compound. So we can see there's no number here, like my eyes deceived me. It's just the O for oxygen, so that means there's just 1. So when you're writing chemical formulas for molecules that contain carbon, hydrogen, and oxygen, always list the carbon atoms first, followed by hydrogen, and then the oxygen. When writing other formulas, write the atoms found on the left side of the periodic table first. So that might be something to put in your notes. There is a way, an order that the elements need to go, and so the most reactive elements are usually over to the highly reactive elements, and it kind of goes down in an arrow, and we'll see that. We saw it in a little bit about the periodic table, but so noting that can help you in writing those formulas. So we have a picture here looking at what ethanol looks like. It shows the chemical structure of ethanol, and another way of writing that formula would be C2H6O. So you can see the 2 C's, the 6 H's, and the O. All right, so when you look back, let me go back to this slide. This is the structural formula of ethanol. And so question 3 says, what are structural formulas, or when are they used, and how do you interpret them? So that's the next thing that we're going to be looking for. All right, so when we get here, we have just a little activity to help us figure out how to create a model of each of the molecules based on their chemical formulas. To unhook the circles, you click and drag where the smaller circles are. So we've got carbon and oxygen. So we would want to put carbon and oxygen together. And that shows what that would look like. If we reset that and we go over to water, we would go to H, and we know that there's 2 of those and 1 oxygen. Okay, so we would see that bond. Actually, I didn't set that up. It needs to go over here. It's actually wanting you to, I don't know if you can flip it around. It might take a little while. So you get the idea of how that should look. They bond together. There we go. Still doesn't look exactly the same. I've got to flip this one as well. So you get the idea of that. There, it's trying to connect to that hydrogen. It keeps running away. So you're just practicing going through together and just building those different molecules so you can kind of see what they look like. And so remember, we use the periodic table for a lot of things, and when we're building different formulas, it's really handy to go ahead and, like I mentioned in some of our lessons in Unit 2, to print out a periodic table for yourself. The Unit 2 gives you a really good one. I also mentioned the website ptable.com. But then adding this 1 plus 2 plus 3 plus, and then 3 minus 2 minus 1 minus will help you as well. So identify which elements carry 1 positive charge, 2 positive charges, and 3 positive charges, and then identify which elements carry 1 negative, 2 negative, and 3 negative, and you flip the card and find the answer. So I'm not sure if there's a little glitch or something in this, but you would use the periodic table. So for instance, hydrogen, lithium, sodium, potassium, rubidium, and cesium. You'll notice if we go back, all of those elements are in the same group or family, and they all have a +1 charge. So if you look at the answer to that, which elements have 1 positive charge, and it shows it there. So just by labeling that periodic table the way it was in the previous picture, you're kind of able to see those charges, and that's helpful when you're trying to identify types of bonds and things like that. So back to structural formula. Sometimes a structural formula is used to represent a covalent molecule. So that answer is number 3, when are structural formulas used? And now we're going to look at how you interpret them. So its name is a clue that a structural formula shows the arrangement of atoms and their bonds in a molecule of a compound. The image at the right shows the structural diagram of the molecule butanol. So look at photo A, and based on the structural formula, what is the chemical formula for butanol? So you can see you've got carbon with 3 hydrogens, so that would be CH3, and then it would be, you've got another right here, C with H and H, so carbon and 2 hydrogens, carbon and 2 hydrogens, carbon and 2 hydrogens, and then an OH. So this kind of shows you how the atoms bond. And so if you're looking at that, what is the chemical formula? You're able to see that it would be C4, because we've got 4 carbons, H10, we have 10 hydrogens, and this one over here is included, and 1 oxygen. So then it says look at photo B, which is over here, and this is the structural formula for glucose, which we also know kind of like sugar. What is the chemical formula for that, for glucose? So it says start with the carbon atoms, then hydrogen, then oxygen. So this one's a little more difficult to count, but you're looking, you have a carbon here, 2, 3, 4, 5, 6. So C6. Then you count all these H's up. There are 12 H's, and there are 6 oxygens. So the way that would look, C6H12O6. Okay, so when how do you interpret those? It tells you they're arranged by basically the atoms and their bonds in a molecule of a compound. So that's how they're interpreted. You're counting basically the letters to represent how many there are. And what do chemical equations show, and how do you write them? So remember, we saw that earlier. Chemical equations, they show the elements that are used. So when you're writing chemical equations, it describes a chemical reaction using symbols and numbers. So that is the answer to question 4. So how do you write them? They are written from left to right. Chemical formulas are useful for writing chemical equations. Just like a math equation, a chemical equation shows a relationship between substances on the left side. Remember, we talked about that being a reactant, and the right side being a product. A plus sign means 2 substances are added together. The arrow, and that's usually you see in the middle, it's kind of like an equal sign. It also, you'll find in upper level chemistry, it means yields. So if you're ever baking, you might see in a recipe like yields 12 muffins. That means it makes 12 muffins. So you can kind of put that reference in your brain. And so if you study the equation below showing the reaction of carbon and oxygen to form carbon dioxide, So a very basic reaction here, carbon plus O2 yields CO2. So that's what's produced. You read this equation as 1 atom of carbon plus 1 molecule of oxygen. Remember, it's a molecule because it has 2 or more atoms. It yields 1 molecule of carbon dioxide. So in the chemical equation, why does the arrow point to the right? The arrow points in the direction of the products formed. So since the products are written on the right, the arrow points that way. Okay, so you're writing the equation, remember, from left to right. If you want to go into more detail, maybe put this example in your notes and label reactants, products, yields. Those would all be good things to include in your notes. Polymers are covalently bonded molecules consisting of repeating chemical units. We wrote that down earlier. These units can form long chains. Each of the repeating units is called a monomer. The chemical formula of the monomer is simply repeated many times in the polymer. Monomers make up polymers just like blocks make up a wall. So I know this is a high school biology topic that you'll learn about polymers and monomers. So in science, there are many examples where components are used to build something more complicated and useful. So you've got the polymers here. Base units are like individual building blocks. Combined, simply they provide units that are useful in simple combinations. So many times, even larger combinations of units provide derived units that are complex but extremely useful. So what's the difference between a monomer and a polymer? If we look up here, you can see that monomer is simply a repeated many times in the polymer. So each of the repeating units is called a monomer. Okay, so that would be, we know a polymer, covalently bonded molecule. A monomer is just a repetition of that, like a long chain. So where we would see these in real life, this is a glucose molecule. Remember we talked about that earlier. Glucose is a monomer. When many glucose molecules covalently bond head to tail, they form a polymer called starch. Starch polymers can be hundreds of thousands of molecules long. There are many different kinds of polymers in living organisms. Spider silk is an example. They're proteins which are made from repeating amino acid monomers. Some man-made polymers are rubber and polyester. So see what happens when the glucose molecules are bonded. So if we look at this picture, okay, you can kind of see where they're joining. It's like they're holding hands. And it's just a repeating line of the same exact molecule over and over. And so, like I said, you will see this and study this in great detail when you take high school biology. All right, so that gets you to the end of the guiding questions. It also gets you to the end of the lesson. So in review, chemical formulas are a shorthand notation for compounds such as water, H2O, or hydrogen peroxide, H2O2. They give information about the types and ratios of elements in a compound. Chemical formulas can provide clues to the properties of a compound. So answer the following questions to explain the differences in writing formulas for ionic or covalent compounds. How many carbon atoms are in C6H12O6? So carbon, you look here, you see the number 6. We know there are 6. Which pair of elements will form an ionic bond, magnesium and iodine, or nitrogen and oxygen? So if you remember back, we talked about one is a metal and a non-metal, the other is 2 non-metals. So if you have magnesium and iodide, that's going to form an ionic bond. And then which pair will form a covalent bond? Calcium and fluorine, or sulfur and oxygen? Sulfur and oxygen are both non-metals, and so you have a covalent bond. So that is all we have in this lesson. It's a lot of information to take in. So your next steps, please make sure that you complete your notebook slide for this lesson, check your flip follow-up session for the week, and then attend Help Lab if you need any extra help.